Data types in Python are really important because to be able to manage our data, to be able to classify our data, we basically need data types. For example, if you want to represent numbers, we have some different data types. If you want to represent our textual data, we need to use some different data types. Here, what we are trying to do is we are trying to classify our data so it can be more manageable and our programs will be more efficient. So here in this one, I will start with numerical data types, then we'll dive into other data types as well. So without further ado, let's start. So let's start with numerical data types. We have three numerical data types in Python, integers, floats, and complex numbers. In this one, I'm not gonna get into complex numbers because in most of our programs, we won't use them. But you just need to know that there is also a data type complex numbers. And at the end of this course, maybe I can mention them as well. So what are important for us are integers and floats. So we basically need to understand the logic of them. Integers are basically some whole numbers, and it's represented by int. It's like 42, minus 15, 0, and 72. And we also have some floats like 3.5, minus 10.7, and so on. These are basically decimal numbers. So to be able to use these data types, we generally use them in our mathematical calculations. And to be able to do that, we need to know mathematical operations. So it's just like in daily math. We have addition, subtraction, division, multiplication, and so on. We also have exponentiation. You have also heard of it, in daily math as well. We also have two different operations that we use in Python and in other programming languages, and it's integer division and modulus operator. So let us talk about them. So to be able to explain it, I will just do a calculation. Here our quotient is 3, and when we calculate it, we have the remainder of 2. Basically, when we do a calculation, we always get this quotient as the integer division of our calculation. For example, when I type something like this, the result will be the quotient, which is 3. So modulus operator gives us the remainder of a calculation. For example, here, when we do something like this in Python, we are gonna get the 2, which is the remainder of our calculation. So I think that makes sense. And when we are done with explanations, I will also do some calculations on Pycharm. So here, let us continue and talk about operator precedence, which is also very important. So multiplication and division comes first when we have addition and subtraction as well. Here, our result is gonna be 25 minus 3, which is 22. But here, there is something different. We have parentheses. And if there is a parenthesis, you should first calculate inside the parentheses, then do other calculations. For example, here we are going to do this first, which is 2, then this, which is 10, and our result is going to be 10. Here we got 22. All right, so operator precedence is also really important. And if we have some exponentiation, that's going to be precedence over other operations. So we can say that first come parentheses, then exponentiation, then multiplication, and division. Then we have just addition and subtraction. Okay, so this is basically how we follow operations in our calculations. That's cool. So how Python understands data types, which is also very important. So if you are coming from other programming languages like Java or C, you might be familiar of some declarations. Like if you want to declare an integer, you need to use int at the beginning of your declaration. But in Python, we don't need that. So what I mean by that, for example, in Java, if you want to represent a string, you basically have to use this string keyword. You have to specify your data type. But for example, if you want to represent an integer, you have to use this int specification. But in Python, we can just do something like this. For example, number equals 42. And Python is gonna understand what this value is specifying, and it's gonna assign the type of it on itself. We don't have to specify the type. So here, for example, when I want to represent a string, I can just say name, and let's say Yasin, and Python is gonna understand this is a string, and it's gonna allocate memory for that string. I don't have to specify the data type. All right, so let us understand the type function and why we need this type function. Okay, we don't specify type of the values, and Python understands everything on its own. But there's a problem here. What if I want to understand it? How can I do that? So to be able to do this, we need to use type function. So for example, we have, let's say, age, and let's say 30. And if I want to understand the type of it, I can just do something like this. Print type, let's say h. Okay, this is my function which gives the type of my variable. And when I just close the parentheses and get the result, it's gonna give me something like this. Class integer. Okay, which specifies that it's classified and its class is integers. Okay, so we are going to use this on our Pycharm and you will have a thorough understanding on it. So let us also understand augmented assignment. So before understanding it, I want to mention something. So what if you want to increment the value of something? For example, you have something called number, which is 3, and you want to increment it by 1. So how could you do that? So in Python, we can do something like this. Number equals number plus 1. That's all right. But here there's a problem. You know, number is 3, and if it's 3, this makes up 4, and number is 3, so it's like 3 equals to 4. So that doesn't make any sense. So here, to be able to understand this, I will mention something. So let us say, you know, I'm gonna write the same thing here. So number equals number plus 1. So Python always calculates the right part of the equation. For example, here it first gets the number, which is 3, and calculates the right side of the equation, and this makes 4. Then Python assigns this 4 to number again. Okay, which is very important. So here I'm going to explain how it actually works in our memory. So I'm going to do something like this. Let us just draw our memory. So it's our memory. And the first time, you know, number is equals to 3. For example, this is our number and it just shows 3. Right? That's all right. So I explained, you know, how we actually represent our values and variables in memory in our previous video. So you can just check them out. So here, when I do something like this, you know, I got the result of 4. Python allocates some memory for this 4. So let us say 4, you know, in some part of memory, it doesn't really matter. Then Python makes this number a reference to this value 4. So here our number is going to be a reference for 4. And here it's not gonna be a reference for 3. Okay, it's not just showing that. Okay, it's not just showing that. So here what we can understand that number is still a reference, but not for 3. It's a reference for 4. Okay, so here what's gonna happen to this 3, which is very important to understand. So we have something called garbage collector, as I mentioned in our previous video. For example, it's just looking for some values if they are not referenced by some variables. And here, you know, our value 3 is not referenced by a number anymore. And garbage collector just take this out from our memory and it just cleans everything. It just collects the garbage for us. Okay, so here number just became reference for our value 4. And what you need to understand, you know, it just calculates the right side first, then assign that value to left side. I think that makes sense. So here, you know, that's an illustration to adding up something, but we can also do something like this. Number plus equals 1. It just does the same thing, but it just looks cool, okay? And most of the programmers, most of the developers use this declaration. So you can also go with that as well. So that's cool. I think we have done with the explanation. So let us do some calculations together. So I'm going to open my Pycharm, and here I'm going to first do some mathematical calculations. So let's say 3 plus 4, and let's say print 4 minus 3. And print, let's say 3 multiplied by 2, and let's say print 8 division by 2. Okay, so let's get our result. I'm gonna right click and run numerical data type. So we got 7 for this, and 1 for -3, and 6 for 3 multiplied by 2. That's cool. And 4.0 for 8 division by 2. But why? Because Python tries to give us some exact results. So to be able to do that, it just gives us the decimal part as well. Nothing to be confused. You just know that Python tries to give us some exact values. That's why it's giving us a float instead of an integer. That's cool. So we also have operator precedence. So let's say print, let's say 2 to the power of 3 and multiply by 4, for example. So here it's gonna do this part first. For example, this is gonna give us 8, then multiply by 4, it should be 32. So let us get our result. Okay, it gives a result. So, but here, if I do something like this, if I use parentheses, it's gonna calculate this side first, then do this calculation, because parentheses comes first always. Okay, so let us calculate this as well. So here we have 12, and to the power of 12 is 4096. That's cool. So how Python understands data types? So here I'm gonna say something like age is, let's say, 30, and let's say type age. So it should give us the type of this variable. So let us just, but we didn't get anything. So this is why we didn't get anything, because type function just gives us the result of our type. It doesn't print out anything. So to be able to print out, we need to use print function. So I'm gonna delete this. So let's do something like this. I'm gonna run my function again, and you see that it's integer class. So that's cool. And we have already used our type function. So let us do it for a string as well. For example, name equals, let's say, John, and I'm gonna print type, let's say, name. So when I do that, I need to get the class of string. So let us run it. Okay, it gives me string as well. So let us see augmented assignment. For example, I have a number called 10, and I want to increment it by, let's say, 5. So to be able to do this, I can say number equals number plus 5. And here Python first calculates the right side of the equation, then assign the result of this to left side of the equation, which is very important. Okay, you need to understand. We first do the right side, then assign the result of this expression to left side of the equation. Okay, so, and when I just print out my number, it should give me 15. So let's see our result. Okay, I can get 15. And instead of doing this, we can just do this something like this. Number plus equals, let's say, 5. And when I do this, I'm gonna get the same result. And it's just a cool way of showing, incrementing a value. And this is basically called augmented assignment. So when you use this expression, plus equal, it just means that you are using augmented assignment. That's cool. So here what we can do more, you can do all of other operations. For example, let's say a minus equal 5. So it's just basically subtracting 5 from our value, which is 10. So let's get it. So it's 5. And you can do it for everything. Let's say multiply equal 5. So I should get 50. And you can do this with other operations as well. So this was a very important one because we have to manage our numerical data types in Python. And I just showed you how to use them, operator, precedence, and more. So just try to do some calculations on Pycharm, try to just play with them. And I hope you got the idea. So that's gonna do it for this video. I will see you in the next one.